video on multiplying square roots. And remember, square roots are also called radicals or roots. We can use those two definitions. So let's look at an example for multiplying. Let's say we had the square root of 4 times the square root of 12. Okay, and so if you remember, we can just multiply them just like we would do integers. 4 times 12. We know 4 times 12 is 48, so that's the answer. The answer will be the square root of 48. And like from the last video, we can also break this down. So we know this answer is the square root of 48. Let's do this over. So we had the square root of 4 times the square root of 12, and we know it's the square root of 48. So we'll put the square root of 48 up here, because 4 times 12 is 48. But we could have also broken this down. We have the square root of 4, which we know is 2, and the square root of 12 we can break down into the square root of 4 times the square root of 3. And the square root of 4 we can break, because it's a perfect square, it is 2, and remember we had a 2 to begin with. So we're left with an answer of 2 times 2 is 4, and the square root of 3 we can't touch. Bring that up. So that's the answer. The square root of 48 is this. And let's check. So I'll leave that there for a minute. So we said that the square root of 48 is also 4 square root of 3. So let's show why. Remember, we can break down the square root of 48. We can do a square root tree. So we know the square root of 48, we can do the square root of 16 times the square root of 3. And the square root of 16 we know is 4. So we're left with that. Let's do a few more. Okay, so what if we had, let's say we had 2 square root of 10. 2 times the square root of 10. Well, we can't do anything with that. You can't multiply an integer and a square root, unless you can break the square root down. So if I had, let's say, 2 square root of 36, well, we know the square root of 36 is 6, and 6 times 2 would be 12. That would be the answer there. We can break the radical down. Again, square root of 36 is 6, and we had a 2 integer outside of it, so 2 times 6 is 12. We can also multiply like this. Let's say I had 2 square root of 10, 2 times the square root of 10, you can write it like that, times, let's say, 3 the square root of 10. So you can multiply the integers, and you can multiply the square roots. So 2 times 3 is 6, and 10, square root of 10 times the square root of 10 is the square root of 100. And we can go further. What do you think? Well, we have the 6 outside waiting, and the square root of 100 is 10, so 10 times 6 is 60, and that would be the answer. Okay, let's do a few more. Try this one. Let's say I had 3 square root of 6 times 5 square root of 6. What would you get? Okay, again, you can multiply the integers. So 3 times 5 is 15, so we have a 15 out. It's free. And then the radicals, 6 times 6 will be the square root of 36. And what do we do from there? Okay, well, the square root of 36 is 6. So the 6 is now free, and we have the 15 that was already free, so 15 times 6, and the answer will be 90. Now, when we break down square roots, let me just look at this. If we had the 3 square root of 6, and you can break down the square root of 6 into the square root of 3 and times the square root of 2, but that doesn't help you. One common mistake that students do is when they break this down, they think that the square root of 3 is just 3, and they try to times it with that other 3 that's free. But it's not free, it's still part of a radical. It has to be free before you multiply it. So again, with this, like we did in last videos, the square root of 6 really can't be broken down, because the square root of 3 and the square root of 2 don't help you. So it's better just to leave it as the square root of 6. So let's try another one. What if I had 5, the square root of 10, times 4, square root of, let's say, 3. What did you get? Again, you multiply the integers, so you would have 20, square root of 30. Now, can you go further? Nothing else helps you here, so you just leave it like that. Let's say we had the 6 square root of 4 times 3 square root of 3. Try that one. Again, you multiply the integers and you'll have 18 square root of 12. Now you can keep it like this, but you can actually do something else, because the square root of 4 is a perfect square. So since that's a perfect square, this would be 2, and 6 times 2 is 12. So you have 12 times 3 square root of 3. And there's still more to do, because 12 times 3 is 36 square root of 3. Now if you didn't do it that way, how do we get 18 square root of 12? 18, the square root of 12 we can break down as the square root of 4 times the square root of 3. And the square root of 4 is 2, right? So 18 times 2 is 36 square root of 3. One more. 5 square root of 12 times, let's say, 3 square root of 4. Do that one. So we have 5 times 3, which we know is 15. The square root of 4, though, before we even do the 15, we know the square root of 4 is 2. So we would have a 6 here. So it would be 5 square root of 12 times 6. We can multiply the integers. Bring that up. So we have 30 square root of 12. But there's still more we can do. So let's write 30 square root of 12. Man, we can break the square root of 12 down in the square root of 4 times the square root of 3. And the square root of 4 is a perfect square, so we would have 2. And 2 times 30 is 60 square root of 3. So that's how we multiply square roots or radicals, or just roots. Okay, let's just go over some terminology. So let's say we had 5 square root of 10. The 5 is the coefficient, just like we had in linear algebra, linear equations. Like if I had a 5x, the number next to the variable is called the coefficient. It's the same with radicals. So here we have 3 square root of 6, so the 3 is the coefficient, and the 6, the number inside the square root, is called the radicand. So that's just terminology to know. So the 6 is the radicand, this is the square root of 6, and that's our terminology.